Hi everyone, welcome back to my YouTube channel. So let's solve this question which was asked in GATE 2022 from the network theory, right? So you have to feel like that you are attending actual paper, and the moment you see the question on your screen, what you think exactly, right? This question might scare you because it looks very big question, but the solution is of only 20 seconds, right? Let's see the question and let's read the question and try to find the solution. So what they have given here is in the question, a linear two-port network is shown in the figure A. Okay, an ideal DC source, voltage source of 10 volt is connected across port 1. Okay, so they have given this is port 1 and this is port 2. Okay, a variable R is connected across the port 2. Okay. As R is varied, the measured voltage and current at port 2 is shown in the figure B. So if R is, as far as the R is there, R is a variable resistance. So this is a plot they have given. Okay. Okay. So V2 versus minus I2. So you have to keep in mind this is minus I2. Okay. So that your resistance will not be negative. Okay. So these axes you have to identify properly. Why they have given minus I2? Because the direction of I2 is into the network. So they have given note that V2 is equal to 5 volt when I2 is equal to 0 milliampere, right? V2 equal to 5 volt when I2 is 0 milliampere, right? They have given. So if I2 is 0 here, I2 will be 0 here, right? From this plot. So your V2 is going to be 5 volt. Yeah. For V2 equal to 4 volt, okay, they have given V2 equal to 4 volt, I2 should be equal to minus 4 milliampere. Okay, so they have given again minus 4 ampere, right? So if V2 is 4 volt, so your I2 is what? 4 milliampere, right? When variable resistance are at the R2, this R, okay, at port 2 is replaced by the load shown in figure C. Okay, so if this guy, if this is R, right, is replaced by, okay, between A and B with 1k ohm, okay, along with a battery of 10 volt, right? This is A and B now. Okay, earlier this was A and B. So, you know, so what will be the current I2? In milliampere, rounded off to one decimal place you have to find. Okay, this is not equal, right? So let's see, let's solve the question, right? So what you have to do here is basically you have to consider this entire network, okay? This entire network as the black box. See, they have given black box here, right? The network is what is inside the network we don't know, okay? So if something is black box kind of a thing, right? Suppose this is kind of a black box, okay? And there is kind of a network, okay? So they have given R, okay, and they have given this V2 and the current is I2. This current I2 is flowing from minus to plus, and this R is varied, and they have given some plot here. So let me draw the plot as well for you. So minus I2, and this plot is kind of a linear plot, okay? So this is V2, okay? This is 5 volt, okay, for 0 milliampere, and for 4 milliampere they have given the voltage has gone down, okay, for 4. So here what is the change is basically 1 volt, and here the change is what? 4 milliampere, right? Okay. Okay, so now this is the network they have given, and obviously port 1 is there, but you don't have to worry about port 1 now, because this plot is given for this variable resistance R, and this is the terminal A and B. So everything is given with respect to this, okay? When you will, you know, in place of variable resistance R, when you will insert one resistance, 1 kilo ohm resistance along with the battery, so what will be the current they are asking, right? So what you can do here is, as far as the current is given, right? So what you can replace, this entire network can be replaced by the Thevenin equivalent. What you can do, you can replace entire black box with the help of VTH and RTH. This is what the practice, actual practice you have to do, right? So any black box can be replaced by, any network can be replaced by, if you look back, if you're looking back to the network, so that network should look like what, one single voltage source, that is VTH or open circuit voltage, and along with the series resistance, right? So this is in between A and B. Okay, so you can connect A and B here. Now in place of R, what you have to do, in place of R, you can connect single resistance, and this is 10 volt. And this is a current I2 what they are looking for, right? In the question, 1K is the resistance, and this is what. Now your job is to find what VTH and RTH, right? And VTH and RTH can be found out from this, from this plot what they have given. So let's try to find the VTH. What is VTH? VTH is basically the open circuit voltage of the network. So if the circuit is open, if the load is disconnected, so current is gonna be 0. Okay. If load is disconnected, it means that the open circuit voltage you have to find, it means that the current is gonna be 0. VOC can be found out at I2 equal to 0 milliampere. What is the value of I2? What is the value of V2 at when I2 is 0? That is, you can say that this is the VTS, that is 5 volt. Directly you can find out from the plot. Now you have to find RTH so there are various method, okay, to find RTH, but one of the very easiest method I'm going to tell you that RTH is basically what, VTH upon ISC. So if already you have calculated VTH upon, now you have to find ISC, that is short circuit current. What is short circuit current? Short circuit current will be basically equal to your I2 only, because after all you are doing all the calculation at port 2, right? This is your port 2. Whatever calculation is being done at port 2, right? So for calculating short circuit current, your V2 should be equal to what? Your V2 should be equal to, or you can say the variable resistance should be equal to 0. Okay, short circuited, so V2 will be equal to 0. So in this x-axis you can say, or the horizontal line, okay, after all this is a linear relation. Okay, they have given linear plot. Let me draw here. They have given linear plot here, right? You can draw, this is linear plot. So this is 5 volt. Okay, this is minus I2, and you can say this is 4 milliampere, and the change in voltage. Okay, if you are changing, if this is 0 milliampere, okay, if there is a change of 4 milliampere, okay, so there is a voltage, how much it is, that is 4 volt, right? So there is a linear, okay, you can see V2 and I2 are related linearly, right? So if you are going to make this x, this slope, okay, this slope is going to touch here on somewhere down the line. Okay, so what you're doing here is you are making your V2 is going to be 0 on this I2 axis. Okay, when V2 is equal to 0 means that is going to be the value of ISC. ISC will be equal to, or you can say where V2 equal to 0, what is going to be the V2 now? The change is what? Now you can see the change. see, this slope should be always constant, right? Because slope is what? Slope is basically going to give you the resistance, right? The slope is going to give you the resistance. V2 upon I2 will give you the RTH. So, you have to just see here, from here to here, what is the change? And from here to here, what is the change? So, if you want to maintain the constant slope, okay, so, so you need to find ISC. For ISC, V2 is going to be 0, right? So, R, so you can determine ISC. ISC is going to be what? 20 milliampere. 20 milliampere. See, for 0 to 4, there is a change of how much? 4 volt, right? And for 5 volt, there should be 20 milliampere. Okay, so you have to keep this in mind, okay, because they have given linear plot. So ISC is going to be 20 milliampere. 5 times you have to, then only you will be able to have the constant slope, right? Okay, so this is going to be 20 milliampere. So let me plug here everything. So this is going to be 20 milliampere. Now it will be 5 upon 20 milliampere. So you can take milli up. So it will be 5 into 1000, right? Or you can say 1000 here upon 20. It will be this. You can calculate further. So it will be what? It is going to be 250. So or you can say it is going to be 0.25 kilo ohm, right? So you don't have to worry about you don't have to write what? You don't have to write the y2 minus y1 upon x2 minus x1 kind of a thing, right? The straight line equation. So this question seems very easy question, right? Okay. I hope this is understood, because after all this is a linear plot. So it will follow linearity, right? It will follow linearity. If there is a 0 milliampere, if there is a 0 milliampere, so they have you have got the voltage 5 here, right? If there is a change of 4 milliampere, so you are getting 4 volt. Okay. If there will be a change of 20 milliampere, you will get what? You can see 0 volt, right? So these things are very important. Okay. Hmm. So now what we can do here is we can plug everything, right? So getting back to the circuit, so RTH is 0.25 kilo ohm and this guy is 5 volt, right? So now you can calculate I2. So I2 is going to be what? I2 will be equal to here we can calculate I2 next page. So I2 equal to, just by applying KVL or directly you can, okay, 10 minus 5 upon 1.25. 10 minus 5 upon 1.2. So it will be giving you in milli, that is 5 upon 1.25 milliampere. Further you can calculate. So if you will calculate this, so it will be 0 0, right? And now you can further compute. I think you can calculate 5 and it will be this, and I think this will be 4. So answer is going to be 4 milliampere. So they are asking up to 1 decimal, so 4.0 will be the answer for this question. So the trick here is what? The trick here is, first of all, you must understand that if you're looking back to the network, so entire network should be, you must be able to replace with the help of VTH and RTH. How to calculate VTH and RTH? From this plot, from this linear plot you must understand, because they have given the linear relationship between V2 and I2. Okay, so whatever changes you are making here, okay, if you want to make this voltage completely zero, so you will have to make current I2 will be equal to what? 20 milliampere, right? Because see, the change here is 1 milliampere, sorry, 1 volt. For 1 volt change, there is a current change is 4 milliampere, right? So I hope you can find the slope now. Slope will be equal to 1 volt upon 4 milliampere, and this slope is going to be same always, right? Slope is not going to be changing, so will be equal to what, 1000 upon 4, and this will give you 2, I guess. Huh? Yes. So this is going to be the RTH only, right? Okay, in case of because there is a linear relationship between V2 and I2. In fact, you don't have to calculate ISC and all, directly you can tell. Okay, slope is going to determine everything. So this is going to be the answer for this question. Okay, so the answer will be 4 milli. Okay, so answer will be 4 milliampere. I hope you understood the solution. We will meet in the next. So whenever question is given, read the question carefully and attack properly. Okay, you will get the answer. Don't start feeling, oh, it looks very big. Okay, this is a very easy question.